Hello and welcome everyone to our video on Amazon Web Services. To start with a short definition, cloud computing is the on-demand availability of computer system resources, especially data storage and computing power, without direct active management by the user. The main advantage of cloud computing is the flexible IT infrastructure, which can be very cost optimizing. AWS was launched in 2006 with a strong focus on B2B. However, today they count over 1 million users of all various sizes. In 2020, AWS generated a total net sales of 45 billion US dollar. The service is mostly charged, however, there are free trials available as well as large discounts on EC2 spot instances, and it is also possible to request 300 US dollar for free trial projects. Since there is an almost endless list of different AWS tools in many different areas, we decided to focus on two main areas. First, I will start with the part about elastic cloud computing, EC2. In the second part, my colleague Felix will give you an introduction to AWS Lambda serverless computing. To start with an introduction about EC2, the main idea behind EC2 is to rent computational power on AWS servers. It is possible to use a virtual Amazon machine image, AMI, which offers an operational system, and this is called an AWS instance. Servers and computational power can be scaled up and down very easily. This refers to the elasticity. In this video, you will learn to set up a free T2 micro instance as a virtual machine running Windows 10. As you will see, the whole process is very easy and I highly encourage you to give it a try. Now I will show you how to create a free EC2 instance and use it as a virtual machine which can be controlled from your own computer. The first thing you have to do is to create a new AWS account, which is fairly self-explaining. Unfortunately, you have to give away your personal data, your address, and also your credit card number. However, if you create a new account, you are also provided with some free trials at AWS, which we also use in this video. After creating the account, you can sign in and start using AWS. If you sign in your AWS account, you can already observe a feature. Since AWS is especially designed for corporates, you can create various account types for employees which can access your server. The root account has unlimited administrative rights, while the so-called IAM accounts can be limited to specific tasks. You just log in with your email address and your password. After logging in, you get to the Aws Management Console. This is kind of the main page of AWS. Here you can go to all services and again see how many different tools AWS provides. The tools are organized in subcategories. So for example, you have the category machine learning and the subcategory SageMaker. If you go down, you come to the getting started with AWS part. And here you will find very helpful information and instructions. And for example, you can go to learn the fundamentals of AWS. This is very helpful. You find a lot of information, explanation, and tutorials about all types of AWS applications here. So if you want to use any tool of AWS, the best way to get started is to go to this page and start learning on it. You can, for example, go to more resources, documentation. You can select EC2 and you can open the user guide for Windows instances. And this is the documentation of what I am going to show you next. You find all explanations and tutorials, and most importantly, you also find the pricing information. For example, here you have a complete list of charges and prices for Amazon EC2, which you find if you follow this link. So back to the AWS Management Console, we are now going to start our own EC2 instance, and we are doing this by launch a virtual machine with EC2 in 2 to 3 minutes. The first thing we have to choose is the Amazon machine image. This is the operating system we will use on our virtual machine, and we can choose between many popular systems as Linux, Mac, and Windows. It is also indicated whether an AMI is eligible for free tier, and there are even some pre-set up AMIs for machine learning, for example, for PyTorch or for TensorFlow. What we are going to use is the Microsoft Windows Server 2019 base, which is eligible for free tier. The next thing we have to choose is the instance type. This is basically the hardware your virtual machine will use. So we have to decide what CPU, storage, memory, and networking capacity we need. The predefined instances range from rather basic up to very powerful. So we have instances with several hundred gigs of RAM. However, we are going to choose the T2 micro instance, which is available for the free trial, and click on Configure Instance Details. So we could change some details here, but it's also fine to go with the predefined settings and click on Review and Launch. Check again if everything is specified correctly and click on Launch. So now we have to create a key pair, and this will allow us to access our instance later. We can create a new key pair, and we have to name the key pair. For example, I name it DAFA with. So next we have to download the key pair and save it to our downloads folder. And this is downloading a file in which our private key is stored, and this is very important to save because we will need it later to configure the password, but now we can finally launch the instance. This process is typically going to take a while. We can go to our main page and to instances running, and our instance is going to show up here after it is initiated. In a few minutes, we can go to our EC2 dashboard and click on Instances Running, and now we will find our eventually initiated instance. So a very important feature here is the instance state. Here we can stop the instance from running, start it again, and eventually terminate the instance if we don't need it anymore. This is a very important feature because AWS is mostly using a pay-as-you-go pricing model. So if your instance is not running, you are typically also not paying for it. So if you don't need the instance, make sure to stop it from running. Well, our instance is completely set up now, and the next thing we have to do is to connect to it. So we are going to Actions and to Connect. And here we choose the RDP client, which is a remote desktop client. And the first thing we have to do is to download the remote desktop file. And after this, we have to go to Get Password. And now we are going to need our private key, which we have stored before. We can go to Browse, and we choose our private key, which we downloaded before, and upload it on the page. Now we can click on Decrypt Password. So this is our password, and we can just copy it in the cache. So if we are going to need it later, we have it. Now I have the remote desktop file in the Downloads folder. On Windows, you can just open it. On Mac, you first need to install a program. For example, you can use Microsoft Remote Desktop to open it. We will open the remote desktop file. And now we have to insert the password which we copied before. Continue. And now the remote desktop is configured. Everything is set up. you can already see that this is Windows 10 and not Mac OS anymore. And what you typically have to do if you use it for the first time, you have to agree to connect to the internet, which you want to do. This is our EC2 instance. You can see the specs we got on the upper right corner again. And now you can use it as a virtual machine for pretty much everything you want to do. For example, if you want to use Python, you can install Anaconda Navigator, and you can install Google Chrome, and so on. You have Microsoft Edge pre-installed on the instance. However, this is really annoying because it's blocking everything. So the easiest way is to directly install Google Chrome using the PowerShell command. Now you can just use the browser to download and install Anaconda Navigator or any other IDE you want to use, just like at your own computer at home. As a little example, I just downloaded the time series notebook of lecture 6 and launched it in Jupyter. And as you can see, everything just works fine. So of course, T2 Micro is not a very powerful machine. It's very simple. But imagine you want to train a very large deep learning model and you have now access to several powerful GPUs and tons of memory, and it would just be much easier than doing it on your local computer. So this will cost you money, but since it is a pay-as-you-go model, it could still be much cheaper than buying the expensive hardware by yourself, and especially if you just need it occasionally and not permanently. You can also use your EC2 instance to run your Flask web application. For this, I created an Ubuntu server. I go through the exact same steps as before, but I choose Ubuntu server as the AMI. We can also use the T2 Micro instance for this. And finally, we have to do some security settings and launch the new instance. After it is initiated, we find our new Ubuntu server instance on our EC2 dashboard, and we can connect to it via the SSH client. What we are going to need is the public DNS. There are different ways to connect to the AWS Ubuntu server. I am just using the Termius SSH client. In order to add a new server, you have to click on New Host. Now you can give it a label. In the address bar, you have to paste the public DNS, which we just copied. Finally, you can add some username. And to get the password, you have to go to keys and upload your private key file, which we downloaded earlier in this video. After you are all set up, you can just click on the label and connect to your AWS Ubuntu server. In the following, I show you a very simple Flask example, which I already have prepared. It is necessary to install Apache 2, WSGI, and Flask. In this directory, I have the run.py file, which contains a very simple print function. I also have the production.wsgi file. This imports the run file as an application. Finally, the default Apache configuration file has to be deactivated and replaced by this configuration file. This will allow us to show our content from the Flask application on the HTML page. Now, if everything worked, you can just again copy your public DNS and open the web page in a new browser window. And now you see the print of the Flask application. So if you're interested in this topic, you can read this tutorial where I also took the example from. Everything is explained step by step and very comprehensible. And this is also a great blog post if you don't want to use EC2 for your Flask application, but put your application in a container with AWS ECS and Docker. This was my part of the video. Thanks a lot for watching and see you.
So, hello everybody from my side as well. I will now just briefly talk about some of the numerous Amazon Web Services I consider as the most important for economic and data science related applications, and then continue with a coding example where I use a Lambda function to connect two of them. First of all, Amazon provides an application named Kinesis. This actually allows you to process big data in real time, for example terabytes of order book data or other financial real-time data like stock prices. Then there is Amazon API, which allows us to incorporate non-Amazon Web Service applications in our Amazon Web Service-backed implementation process. Another important service is the DynamoDB application, which is actually nothing else than a cloud database where you can insert your data you, for example, streamed with Kinesis and then work with it. The next service, called S3, is actually comparable to Dropbox, where you can upload data, for example CSV or JSON files, and then share them globally if necessary or just keep them private. Furthermore, you can use the data uploaded to S3 to automatically set up a DynamoDB database once something is uploaded. However, to achieve this, you need Lambda, which can be seen as the core of all these services that connects them, because in Lambda you can create functions in several supported programming languages that have access on the other AWS applications. So now I want to give a brief introduction in what you can actually do with the mentioned features of AWS and Lambda. Therefore, I will write a Lambda function that transfers CSV data I upload in the S3 cloud storage, which is then automatically imported in the DynamoDB database. So we start after login on this screen, and first we have to go to S3. Here we have to create a bucket. And in this bucket we will upload our data, our CSV data. So it's straightforward, just choose a name and click on create bucket and you're good to go. I already did this, and in this bucket I uploaded some CSV file. This file contains an actor ID and first name, surname and a salary for some data. Next we have to go to DynamoDB to create a database where we can include the data. Therefore click on tables and create a table. Choose a name and choose a primary partition key. It's quite sensible to use the same primary key that is used in the CSV file. I selected a number and call it actor ID as well. Next we have to go to the IAM. This is the Identity and Access Management application. And what we have to do here is we have to create a rule. The rule is actually to allow Lambda to access to S3 and DynamoDB. Generally, just click on create a rule, but I already did this, and the basic structure looks like this. I gave full permission for all resources to DynamoDB and S3 and further to CloudWatch. CloudWatch is just for better code interpretation and further for writing logs. Next, what we have to do is to create a role that actually consists of our rule. And I did this by just creating a role, then click on Lambda, and then it's actually assigned to Lambda. So I've done this as well, and I coded S3 to DynamoDB. And as you can see, it includes the predefined rule and another rule. This one is just for allowing Lambda not to only use CloudWatch, but write logs to CloudWatch directly. So once we've done this, we can actually go to Lambda. And Lambda works straightforward. So I will give one example for a hello world function. Just go on create function. I name it hello world and use Python 3.7 as support programming language. And in general, what we would do at this point is we would choose the role we just created, S3 to DynamoDB role. But since it's just a hello world function, we actually don't need this. So I create the function. It usually takes a minute or little bit less than a minute. We should be good soon. There we go. So what you can see here is the general syntax of a lambda function, and this function is already finished, so we don't have to add anything, but we have to configure a test event. Call this hello world as well, create it, and then we can test our function. So we can see now the execution results, and this is kind of the console from Lambda and the debugger as well. So if we get an error message, we would see an error message down here, and here we see the response from our function, and it does nothing else than giving us this print that we wanted to have. But you have to acknowledge that in Lambda there is a general structure, so it's just conventional and it's forced. So you have to have always this structure where the body comes first and only then the actual string. Okay, let's now go and create a function that actually can import our data. So I already did this and called it S3 to DynamoDB. And here is the function. So first of all, what we would like to do is to create a trigger. Just go on create trigger and choose S3, choose the bucket, and for example choose a suffix. So now if I create this trigger, every time I upload some CSV file to this certain bucket, my lambda function will be called. Then let's give you a brief overview about the code. First of all, we have this function. This is a conventional function, so it's always the same, and we will have an event that is passed to the function, and this will be the object that we pass. So yeah, we have then to define some things like the region. So we are currently operating from Europe, Frankfurt, so EU Central 1. And this is very important because the DynamoDB database will only work if you choose the region as the region you are currently operating in. So otherwise there will be a message error or an error in the debugger. But the debugger is often very ambiguous, and it's not straightforward to find solutions to the problems that are shown there. So you kind of have to do some search, and it's unclear if the table is named wrong or if it's the region or whatever. So it's the debugger is quite inferior to other debuggers I usually use. Next, what we have to do is to implement some clients. So these clients allow us to interact with the other AWS applications like S3 and DynamoDB. But to do this, we have to import, of course, some library. So first CSV. This is just to read the CSV file. But Bodo3 is the important library. You can just check 1 second. So if you go to Bodo3 doc, there's documentation in great detail, and it's very good to read, and you can get the syntax from here. So another good thing to know. Once we created these clients, we can actually define the bucket source and the key source. The key source is nothing else than the file name, and the bucket name should be, of course, my bucket Felix, the bucket that I created. So I apply some logic here that is not too easy to understand, but we can just understand it by configuring a test event. So this time, if we would configure a test event, we can't use the hello world sample. We have to use the S3 put sample, and this has this type of structure. So first you see an array with records, then some site information, and then this S3 array where the actual bucket and name is contained, and the object where the name from the CSV file is contained. So if we create this and then use the get object function to write this to this variable with the properties as described, we could then just execute this code without all this and test it. And what it would show us would be, I can just show you for a second. I executed this code before. We go to CloudWatch protocols, and then you can see it looks like something. It looks like this. So it's the same structure again that is passed. Good. Now, once this is done, we can actually read the CSV file, but it is important to mention again, all these structures in Lambda are always of this body type, so you have to read the body of the object, so of the response from this getObject function, and in the body the data itself is contained. So we can split by a line space. I just did it because I designed the CSV file like that, and afterwards we can actually use the CSV reader method to split the data by the original delimiter, so the comma. Once this is done, we can just iterate over all objects in this CSV container and assign them to our DynamoDB table with the put item function. So we wanted to put to the table name movie characters. That was the name we created, and we want to create it in a certain way. So for the first element, of course, that is the ID. Then the first name is the second element, and so on and so forth. And I just defined that this is just for number and string, and yeah. Then I converted it to a string. So if we execute this, we are actually good to go to execute right now. So we can do this. And as you can see, it worked. Here we see the data from the CSV file I uploaded. And if we go to DynamoDB and click on the table and then click on show elements, it should now show our data. Yeah. And this is very useful. You can access this from everywhere now. So the data is in the cloud right now, and we can work with this data. And every time we have to upload similar CSV files or something like this, I could just include them in the same bucket, and then this function would be executed directly. So if we have more files of this structure, maybe like stock data or something like this, with the same structure, we can just consequently upload it, and yeah, that is a good advantage. So let's now come to the conclusion. To summarize, EC2 was very convenient to implement and can be useful, especially for data science. It is also very useful if you have no major computing capacities, because you only own a laptop with no computing power due to a weak CPU. In contrast, the general AWS services with Lambda were not that straightforward to use, and the data science applications are limited. In general, I wasn't really satisfied by the tested Amazon Web Services. They just didn't feel mature, as you're, for example, unable to use flow data in the DynamoDB database. Nevertheless, the services can be really sensible if you, for example, develop an app that has only frictional usage, so you can avoid to host an own server. However, for the average data science student, this is definitely not a must-have, in my opinion. There are substitutes that work better and are easier to learn as long as you don't use terabytes of data. So, thank you for your attention. I hope you enjoyed it, and we could teach you something about AWS services, and see you soon.